Hello students, this is Mrs. Tran-Bloom recording for our note today, graphing reciprocal function. So the title today is called a reciprocal function. Sometimes we also call it the rational function, okay? So the parent function, students, is always y equals 1 over x. Now we have studied the HK form before. The h is always going to be horizontally shifting either left or right. Then we have the k value that's going to go up or down, and then we have the a value that has a transformation of either reflecting over the x-axis or vertical reflection if it's negative. And then if it's bigger than 1, then we know that's a vertical stretch, and if it's smaller than 1, we know it's going to be a vertical compression. Now I would like for you guys to also write this form down. Now if we write a times, students, 1 over x minus h plus k, this is slightly easier for us to recognize, but the a is being multiplied, so you can see that it's going to be a stretch or compression or a vertical reflection. Okay, number 1, graph the parent function. We are going to graph y equals 1 over x, then find all of the characteristics. We are going to pick a couple points here, but before we go and do that, let's talk about the restrictions. So we know that this can never ever be 0 for the restrictions. Now in math, whenever we are graphing and we want to graph something that's not equal to 0, we graph this thing called the asymptote, okay? So this is x equals, in this case, really not equal. So it's going to create this asymptote, okay? So this is what we call a vertical asymptote. Vertical asymptote. Now, a vertical asymptote represents what x cannot be. Sometimes we have more than one, but in our class this year, we are only going to have one vertical asymptote. It represents what x can never be. But when we write the equation, students, we write x equals to 0, okay? So that means we cannot pick 0 for our x values. So that means we can pick some negative values, some positive values, just not 0, okay? So let's pick, let's say -2, -1, and yes, we are going to pick -1/2. Then because we can't pick 0, we're gonna go and pick some positive numbers such as 1/2, 1, and 2. Then we are going to plug into our y equation here. So when x is -1/2, 1 divided by, when x is -2, my bad. When x is -2, 1 divided by -2 is going to be a -1 over 2. When x is -1, 1 divided by -1 is just simply -1. When x is -1/2, 1 divided by -1/2, here we go, let me do the work. 1 divided by -1/2. Then we keep and change and flip, remember? So this is going to say keep the 1, change it to multiplication, flip your -2 over 1. So in essence, 1 divided by -1/2 is just now a -2. So we are just going to flip your -1/2 into a -2. So whenever you're dividing by 1, then your answer is going to be its reciprocal. 1 divided by +1/2, guys, by now we know is going to be 2. And then 1 divided by 1 is 1. 1 divided by 2 is now a 1/2. As you can see here, and we're going to do some experiment, okay? So these are the 6 values that we're going to use, and then we'll come back and talk about other stuff. So let's plot it. When x is -2, we have a -1/2 down here. When x is -1, we have a -1 right here. When x is -1/2, we actually have a -2, and we're going to keep on going, okay? So let's say that these are just extra points that I want to demonstrate something. Let's pick -10. So y, guys, is 1 over x, right? So y, the parent function, is 1 over x. Well, 1 divided by -10, guys, is going to be -1 over 10. So when x is going to be a -10, I'm getting closer and closer to the y-axis. Now, what if I pick -1 over 10? So 1 divided by -1/10 is going to be a -10. So when x is so small, very, very close to 0, y is getting down here. So if we were to keep on going and pick, remember, just because we pick 6 values doesn't mean that's all that is, right? It's gonna keep on going. So this is gonna keep on going downward forever, and this is gonna keep on going, going to the left forever. Yes, feel free to go off the grid or rescale. You don't ever have to stay on the 10 by 10. So as you can see, when we pick a very large negative number and when we pick a very small negative number, we never really got anything that's going to turn out to be 0. So let's go and plot. Let's make sure our points are really clearly plotted. When we plug a half in, we're going to go up to 2. When we plug in a 1, y is 1. And when x is 2, y is a half. So it goes like this. And for the same purpose, guys, I'm going to demonstrate some more. What if we go and pick positive 10? When x is positive 10, 1 divided by positive 10 is 1/10. So 10 is over here. Again, it's not 0, but it's definitely getting closer and closer to 0. When x is, how about really small, like 1 over 10? So if we pick 1 over 10, 1 divided by 1/10 is now 10. So, and even if we pick like 100 or 1 over 100, our y value will never ever be 0. So that's going to be another, okay, so this is our graph. Okay. So what's happening is, guys, we can't ever have a value equals to 0 for the y. That means y can't be 0 either. So that will create a horizontal asymptote. Okay. Horizontal asymptote is y equals to 0. It represents what y cannot be. Okay, so again, horizontal asymptote represents what y cannot be. Vertical asymptote represents what x cannot be. So we use these dashed lines. I'm going to make it bigger for you guys to see. So dashed lines to represent asymptotes. Now, as you can see, if you put the dashed lines on the x-axis or the y-axis, you can't really see it. So what happens, students, is you need to go a little bit beyond and both, and don't be afraid to go above the grid. Keep on going and keep on going this way as well. So asymptote, they need to have dashed lines. So let's fill in some values here. Because it is the parent function, your h and your k will be 0, 0. We don't have any x or y intercept because we do not touch the x and the y intercept. Your domain is going to be all real numbers, okay, except 0, because we said x can't be 0. So all real numbers except 0. Now, you also need to know how to write it as an interval notation, or negative infinity 0 union 0 to infinity. Your range is very similar. It's going to be all real numbers, okay, except 0. But also write it the same way. We are going to write it negative infinity to 0 union 0 to infinity. Increasing interval. So let's look at to see if this is increasing or decreasing, okay? So if we're going from left to right, as you can see here, it's confusing, but left to right on the red, okay? If we're walking from red to on the red here, we are definitely decreasing, okay? It gets steeper as we are closing to 0. So it's going to be decreasing from negative infinity to 0, definitely. And let's try the right side. Oh, this is really steep here, okay? But again, it's still decreasing. It's getting closer and closer to the x-axis. Never touch the x-axis, just very close to the x-axis. So it's decreasing over the entire domain. That means increasing is NA. It is definitely 1-to-1 because it passes the horizontal line test. No horizontal line test will cross over more than once. Okay. Now, next is going to be a horizontal asymptote. Yes, you have a horizontal asymptote. We talked about this right here. Horizontal asymptote is what y cannot be, so we're going to write y equal to 0. Okay, so I'm going to put a star on here. Horizontal asymptote is what y cannot be. We do have a vertical asymptote. A vertical asymptote is down here. It represents what x cannot be. That means we have x equal to 0. Okay, and I'll spell it out. what x cannot be. Okay. And let me pinch it in, and that's the entire parent. So the 6 important value for the parent function, students, are these right here.